Today we are going to find the power series for the function natural log of 1 plus x, and the general formula for power series is f of x is equal to c naught plus c1x plus c2x square plus c3x cube plus c4x4 up to so on. The powers of x keep on increasing, and there are constants written as coefficients of these powers. So for our ease, we take x is equal to 0 because that will make all of these terms 0, and we can easily find the value for c naught. Basically, we are interested in finding this power series, and for that we need to evaluate these constants. So first constant can be easily evaluated by taking x is equal to 0. So when we put x is equal to 0 in this equation, we get f of 0 is equal to c naught plus c1 times 0 plus c2 times 0 squared plus c3 times 0 cube up to so on. So f of 0, the function is f of x is equal to natural log of 1 plus x. So f of 0 means we just need to put 0 in place of x in this function. So we get natural log of 1 plus 0 is equal to all these terms will become 0, and we will be left with c naught. So c naught is equal to natural log of 1 plus 0 is 1. So c naught is equal to natural log of 1, and natural log of 1 is equal to 0. Why? Because what we are finding is that what power should e be raised to get 1, because the base of this logarithm is e, and because it's a natural logarithm, and e raised to power 0 is equal to 1, so c naught is equal to 0. So we have found our first constant, and now we need to find c1, c2, c3 up to so on to evaluate our power series. So for that we can use the derivative of our function, and not our function, basically this power series, this general power series, and the power series, when we take its derivative, we get f dash of x is equal to c1 plus 2c2x. We apply power rule, and when we take the derivative of this term, we get c1. When we take the derivative, because here the power is 1 and the power gets in front, so 1 times c1 is c1, and the power gets reduced by 1, so 1 minus 1 is 0, so x raised to power 0 is 1, so we are left with c1 times 1, which is c1. Similarly, here the power will come in front, and we will get 2c2x 1, so 2c2x, and so on. So the derivative is c1 plus 2c2x plus 3c3x squared plus 4c4x cubed up to so on, and we are interested in finding the c1, so we'll put x is equal to 0, and these terms will become 0, so we'll be left with c1 on the right hand side, and on the left hand side we need to take the derivative of our function, which was natural log of 1 plus x. So if f of x is equal to natural log of x, its derivative is 1 over x, but here we have 1 plus x in place of x, so that will make no difference apart from this, that the denominator will now be 1 plus x in place of x. So the derivative of our given function is 1 over 1 plus x. Normally we take derivative of whatever we are taking natural log of, and when we had x, the derivative of x with respect to x is 1, so we don't write it. And here we are taking the natural log of 1 plus x, so when we take its derivative, it's same 1, because the derivative of 1 with respect to x is 0 because it's a constant, and the derivative of x with respect to x is 1, so 0 plus 1 is 1. We don't need to write 1 beside this thing. So we get our derivative, and we need to put 0 in place of x in this derivative. So when we do that, we get 1 over 1 plus 0, and 1 over 1 plus 0 is 1 over 1, which is simply 1. So c1 equal to 1. So for next constant, we need to take the second derivative, or the general power series, and that is f double dash of x, and applying the same power rule, we get 2c2 plus 6c3x plus 12c4x squared up to so on. We are interested in finding the value for c2, so when we put x is equal to 0, all of these terms they become 0, and we are left with 2c2, and on the left hand side we need to evaluate the derivative of our function, second derivative. So if the first derivative is 1 over x, meaning x minus 1, x raised to power minus 1, because when we shift the denominator to numerator, its power changes sign. So what happens, we want to take the derivative of x raised to power minus 1, and we can do that by using power rule. Power gets in front, so minus 1 comes in front, it becomes minus times x, and we reduce power by 1, so minus 1 minus 1, so we get minus times x raised to power minus 2. And if we want this negative 2 to be positive 2, we need to shift this to the denominator, so we get minus 1 over x squared. And here we didn't have this x, we had 1 plus x, as you can see here. So when we take the derivative of this thing, this was our first derivative, and based on this pattern, we get a square in the denominator. But here the denominator, in case of first derivative, the denominator was 1 plus x, not x, so in the second derivative it will be 1 plus x squared, not x squared. So we have our second derivative, and to find c2 we just need to put 0 in place of x in this second derivative, so we get minus 1 over 1 plus 0 whole squared, which is minus 1 over 1 squared, is equal to 2c2. So we get minus 1 over 1 equal to 2c2, and minus 1 is equal to 2c2. For c2 we need to shift this 2 to the other side, and 2, when it gets shifted to the other side, it will be divided, so c2 will be equal to minus 1 over 2. So I'm going to evaluate one more constant, and then we will be able to write our series. So now for that constant we need to take the third derivative, and for that, again, if we have second derivative equal to minus 1 over 1 plus x squared, which we have in this case, we can write it as minus 1 times, if you want to shift this entire thing to the numerator, its power will change sign, so 1 plus x raised to power minus 2, and when we apply power rule we get minus 2 times minus 1, which becomes 2, and times 1 plus x, and when we reduce power we get minus 2 minus 1, so this becomes 2 times 1 plus x raised to power minus 3, and when we shift this to the denominator we get 2 over 1 plus x raised to power 3. So this is our third derivative, and we'll put 0 in place of x in this thing. So on left hand side we have f triple dash of 0. So that is simply 2 over 1 plus 0 whole cubed, 2 over 1 cubed, 2 over 1, which is equal to 2. And on the right hand side, when we take the derivative of the second derivative, it becomes 6c3 plus 24c4x up to so on. So apart from this term, the next terms involve x in them. So when we put x is equal to 0, these terms become 0, so we get 6c3 on the right hand side. So we are interested in c3, so 6 will be divided on the other side. So 2 by 6 is equal to 1 by 3, so we get c3 equal to 1 by 3. So now we can write the power series for our function, and that is natural log of 1 plus x is equal to c0 was 0, c1 was 1, c2 was minus 1 over 2, c3 was 1 over 3. So putting these values, we get 0 plus 1 times x plus minus 1 by 2 times x squared plus 1 by 3 times x cubed up to so on. And don't need to write 0 here, so this will become 1 times x is x, minus 1 by 2 times x squared is minus x squared by 2 plus x cubed by 3 minus up to so on. Signs are alternating, so that's why I have written negative here, because plus minus up to so on. So this is our power series for natural log of 1 plus x.